All right, welcome to The Explainer. We're all living in this world that's just drowning in data. So today we're going to look at the tool built to tame that flood, Apache Spark. This is the engine that really turns massive, chaotic information into clear, valuable insights.
So, you've probably heard the term big data, right? I mean, it's basically the digital trail we all create every single day. Social media posts, online shopping, even the sensors in our cities. But here's the thing, all that information is just noise until you can actually process it. And that is the monumental challenge businesses are facing right now.
And that really is the core problem, isn't it? I mean, in this overwhelming flood of information, how on earth do you find the signals that actually matter? Well, that's precisely the problem Spark was designed to solve. Okay, so here's our roadmap. First, we'll get a handle on the scale of this data deluge. Then, we'll meet Spark, the engine built to tame it. We'll see how it organizes all that chaos, how it deals with data in real time, and finally, the cool part, how it learns from it to make predictions. All right, first up, the problem itself, the data deluge. Because, to really get why Spark is so revolutionary, you first have to appreciate the sheer scale of the challenge it was built to overcome. So, the whole game changed with technologies like Hadoop. All of a sudden, storing data became incredibly cheap, like hundreds of times cheaper. It got to the point where it was actually more expensive to spend time deciding what not to save. So what happened? The floodgates opened. Companies just started saving everything. And that's how we got the data deluge we're talking about today. Okay, so with all this data just piling up, storing it wasn't enough, right? A new kind of engine was needed. Something fast, something flexible, and something resilient. And that, my friends, is where Apache Spark enters our story. So what is Spark exactly? Well, you can think of it as this powerful general-purpose engine for big data. And the real keyword here is unified. See, before Spark, you needed this whole complicated chain of different tools for different jobs. Spark just brought it all together. Data cleaning, analytics, even really complex machine learning, all into one single powerful system.
Now, here's where it gets really clever. How Spark handles failure. It does this with a concept called lineage. And honestly, the best way to think about it is like a recipe card. Spark doesn't just store the final cake. It remembers every single step it took to bake it. So if a server crashes mid-calculation, no big deal. Spark just looks at its recipe, the lineage, and rebuilds that lost piece of data. This resilience is absolutely huge. It's what lets companies run these massive jobs without constantly worrying that one little failure will wipe out hours of work. It was a total game changer.
Okay, so we have this powerful, super resilient engine. Now let's dig into how Spark actually starts to bring some structure to all that chaotic, raw data. A huge part of Spark's flexibility is the data formats it can work with. Now, two of the most important ones are Parquet and JSON. Think of Parquet like a hyper-efficient filing cabinet for analytics. Let's say you have a massive table with 1,000 columns, but you only need to look at 2 of them. Parquet is smart enough to only read those 2 columns, which saves an incredible amount of time. And then you have JSON. It's the lightweight language of the web, perfect for all the data flying around from apps and APIs. Yeah, and this quote just hits the nail on the head. See, the older format, XML, was kind of bloated. It had all this extra baggage. JSON gives you the same structure, but, well, it's fat-free. And that's pretty much why it completely took over as the standard for web data. Okay, so a really common thing you have to do in data processing is join different data sets together. Let's take the Yelp data set, for example. You might have one giant table with millions of reviews and another table with all the user information. By doing what's called a join on the user ID, which is in both tables, you can connect every single review to the person who wrote it. All of a sudden, you have a much, much richer picture for your analysis. Now, handling security across a massive distributed system, that's really complex. Spark uses a protocol called Kerberos, and there's this great analogy for it. It's like going to the movies. First, you get a special master ticket. Then you take that master ticket to a special counter to get tickets for the specific movies you want to see. The cool part is, you don't have to prove who you are every single time you want a new ticket. It's a really clever way to handle access securely and efficiently across this huge system. All right, so far we've mostly been talking about processing data that's just sitting there, already collected. But what about data that's constantly flowing in? Like from stock markets or live social media feeds or weather sensors. Well, this is where Spark's streaming superpower comes into play. And this visual illustrates the core idea perfectly. See, instead of trying to process an infinite river of data all at once, which is basically impossible, Spark Streaming does something really clever. It just chops up that river into tiny, manageable buckets, or micro batches. And then it just feeds those little batches into the very same powerful Spark engine we've already been talking about. What that means is you can apply all the same complex logic and analysis to live streaming data that you can to your normal static data. It's brilliant. But when you're dealing with real-time streams, one of the most critical things to get right is time. And there are two kinds of time. There's event time. That's when something actually happened out in the real world, like a sensor taking a reading. And then there's processing time. That's when your system finally saw that event. Now, if you have network delays, those two times can be really different. And trust me, getting that distinction wrong can lead to some completely incorrect conclusions. And this live data, it flows in from everywhere. So to manage this absolute fire hose of information, Spark often partners up with a system called Kafka. The best way to think of Kafka is as a central organized buffer. It's like a massive shock absorber that can take in these huge, chaotic streams of data and then feed them to Spark in a nice, orderly way for analysis. Okay, we've collected our data, we've organized it, we've even processed it in real time. Now it's time for the payoff, the final, and honestly, the most exciting step in our journey. Using all that data to learn, to find patterns, and to make predictions with machine learning.
So before a machine can learn anything, you have to turn your data into numbers, into what are called vectors. But not all data is the same. Some of it is dense, meaning there's a value for pretty much every feature. But a lot of data is sparse, meaning it has tons of empty values or zeros. Now, Spark is smart about this. It uses different, more efficient ways to store those sparse vectors, which saves an absolutely incredible amount of memory and processing power. It's just another example of that built-in efficiency Spark has. And here, this is where you can really see the magic of what's called unsupervised learning. Look on the left, we have a raw scatter plot of data. Let's say it's house prices versus lot size. It's just a cloud of dots, right? There's no obvious pattern. But when you apply an algorithm like k-means in Spark, the system automatically discovers the natural groupings, the clusters hidden within that data. You can see it on the right. It finds the hidden structure all by itself. It's amazing. Now, the other main type of machine learning is called supervised learning. And here, it's like we're teaching the algorithm. We give it a bunch of labeled examples from the past. For instance, you could build a simple decision tree from data about whether or not people played tennis based on the weather. The algorithm learns the rules from all that history, and it builds a model that can then predict what will happen with new weather conditions it's never seen before. And obviously, this isn't just for predicting tennis games. These techniques are used to solve really critical real-world problems. For instance, using medical data from the Pima Indians Diabetes Database, Spark can be trained on features like glucose concentration, blood pressure, age, and so on. And it can build a model that helps predict whether a person is at risk for diabetes. That kind of thing can literally save lives by enabling early intervention. So there you have it. We've seen how Spark can take us on this entire journey, from a chaotic deluge of raw data all the way to structured, real-time, and predictive insights. It's an incredibly powerful tool for navigating the world we live in today. And that really leaves us with a final thought to chew on. If data truly is the new oil, what kind of future are we going to build with engines like Spark that can refine it?